So, hi everyone, my name is Christian Dominguez, and today for this workshop, I'm presenting Easter wave contributions to seasonal rainfall over the tropical Americas in observations and a regional climate model. So first, I would like to start my presentation by defining what is an easter wave. So an easter wave is a tropical disturbance of the tropical easterlies that consists of a withdrawal of pressure where you can find cloudiness, you can find rainfall, you can find also an ascent motion. And in the other side, you have a high pressure system where you can find subsidence, clear skies, fire weather. So these Easter waves are very important because they can form tropical cyclones and also they can produce rainfall over the tropics. And this leather characteristic is not very explored in many papers. I mean, this paper that I'm presenting today here is the first one in exploring the rainfall produced by Easter waves. So in this paper, we just define three regions, the tropical Americas, the main developing region, and another South America. So I'm just presenting a few results here just to make short my presentation. And the first key finding is, for example, you can see here in figure A that the Easter waves can produce like 700 millimeters here in the Eastern Pacific Ocean. And in this region, you can find other tropical phenomena like the ITCC or the tropical cyclones that can produce a very important precipitation. But the Easter waves can contribute up to 60% of the regional rainfall over this region that is very near to the coast of Mexico and Central America. And it's very interesting to see here that the Easter waves are very active on the Eastern Pacific Ocean. Also, the precipitation produced by Easter waves can have a climate variability. I mean, we can have years when the Easter waves produce a lot of precipitation. For example, this year in 2000, this timeline represents all the precipitation that is only concentrated on the northern South America. And the blue bars represent the accumulated precipitation from May to November. And the green bars represent here the precipitation produced by Easter waves. So you can see that there is like a seesaw. There are years when the Easter waves can produce a lot of precipitation, but there are other years like 2005, the Easter waves produce less precipitation. So this is very important to analyze because these regions can have problems when they don't receive enough precipitation because they can have very few water resources for different purposes like socioeconomical activities. And we also explore here, for example, how the regional climate model, that is the WRF model, can simulate the Easter wave frequency. So we have here 10 members. The first one is a combination of different radiation schemes, different cumulus convection, microphysics, and the planetary boundary layer. For example, letter A represents the first letter is letter C. That means that the CAM radiation scheme was used. The second letter represents the cumulus parameterization. K is for Cambridge, and M is for the new Arakawa skewer, and T is for TEC. The third letter represents the microphysics scheme. 6 represents the sixth moment, and T represents the Thomson scheme. And the fourth letter is for the planetary boundary layer. And we have only two schemes. The first one, M, represents the Mellor-Yamada scheme, and the other letter that is way represents the Yonsei University scheme. So you can see here that some of the members, for example, letter A, letter E, letter F, can have adequately skilled to represent the observed history wave frequency for the period of 1990 to 2000 when compared to the frequency obtained from the ERA interim reanalysis. But other members have some problems. For example, here, letter I or letter K have very few history waves. And we also explore how the Easter waves can contribute to the seasonal rainfall. Remember that for this paper, seasonal rainfall is defined as accumulated precipitation from May to November. So here is also a very similar message that the previous one. For example, some of the members have a very good ability to produce precipitation over the Central America. For example, letter A, letter G, letter F have a very good skill to reproduce what is observed in the interim reanalysis. But other members have some problems. For example, letter A, letter K, and this is related to the frequency that is simulated in these members. So some of the members have very low Easter wave activity, so consequently they won't produce enough precipitation when compared to the ERA interim reanalysis. So here you have the messages to take home. So the first one is accumulated seasonal rainfall depends on Easter wave activity, since they produce up to 50% of the accumulated summer precipitation over northern Southern America. Whereas the simulated Easter wave precipitation over land is barely represented, the Easter wave contribution to seasonal rainfall over the tropical America's landmass is adequately captured by most of the members. And we really need more observations located outside the Niño 3.5 region. This information is necessary to improve the representation of Easter waves in reanalysis and weather forecasts. I mean, Easter waves are very important because they can produce a lot of precipitation in the tropics. So we need more for example, buoys located over the ocean, or perhaps some campaigns that can measure a vertical profile of these tropical phenomena. So if you have any questions, please don't hesitate to contact me. You can reach me out by email or you can follow me on Twitter. And thank you so much for watching.